Hello everybody, my name is Parth Padivan and currently I will basically going to solve a JEE advanced physics problem regarding electrostatics. This problem is particularly targeting towards electric flux and Gauss applications. It is being said that we are basically having a ring of radius r which is having a uniform charge of density lambda being uniformly distributed around its circumference, and we are basically having a sphere, as you can see in my diagram, of radius r by 2 or diameter r, uh, uh, and the centers of these two figures are joining through a straight line, a straight horizontal line. We need to find the maximum flux through the sphere in this process. Means it has been said that um, this ring is moving towards this ring is basically moving towards the sphere, and what will going to be the maximum electric flux which this ring will basically going to suffer with respect to this sphere. So this is the question which we need to answer here. Okay, so it is just asking us that what is that instant in which the most amount of electric field lines will going to cross through the sphere when this ring will going to have an interface with the sphere. We just need to answer that thing here. Okay, so now let's just straight went into the solution here. Okay, we also need to keep ensure the diagram also being drawn every time correctly. First of all, let us first have that sphere. So let us suppose that we are basically having this as that sphere which we were originally talking about, having its diameter as r or radius r by 2. Okay, both are the same thing. And we are basically having a ring. Okay, a ring of diameter 2 or radius r. Okay, like this, having their centers in the same line. Okay, so it is basically having its diameter as 2r. I know that this is not like a ring, but you can adjust the fact that I'm basically having a very bad handwriting or basically documentation here. And it is basically having a uniform charge density lambda being spread across it. Now, when it will basically going to cut itself, okay, it will basically going to have its parentheses like this, 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 like this. Okay, so it will going to be having interfaces like this because it is a ring and it is not a sphere. So that's why I'm considering only one dimensional diagrams. Okay, now we need to choose that instant at which most amount of the part of the circumference of the ring is inside the sphere, and that part is the part when it has crossed the center, and because that's extremely obvious because after that it is decreasing and before that it is in decreasing, because before that it was increasing at the point it is in its maximum stage, and then it will again going to start decreasing. Okay, because we can see here extreme clarity that this lens is having the maximum curvature. Okay, compared to this curvature or this curvature, this is the maximum curvature you can basically see. So one point that we had concluded from here is that we will basically going to have the maximum flux, the maximum electric flux when ring will cross the center of the sphere. Okay, so pretty nice. This was exactly the point which I need to mention here. So I will again going to draw the sphere. This time it is like a perfect circle having radius, oh sorry, diameter of r, and then I'm basically having attached with it another ring type structure having the diameter 2 times of r. All right, and we also need to clarify the fact that this is r divided by 2 here. Okay, so here will going to be the center of this bigger ring. Okay, because this is r by 2 and it needs to be in the perpendicular bisector. Okay, it needs to be in perpendicular bisector, like here. Let us suppose that the center of this ring is here, and we can simply draw perpendiculars here. We can simply draw a line to represent the fact, or we can simply have a bold line representing the fact that this and this are equal to each other, with r divided by 2 and r divided by 2 here. Okay, this is the first thing that we need to take into our consideration here. Then what I will going to do here is that I will basically going to drop tangents here. So this is the first tangent here, and this is the second tangent which you can expect here. Okay, so these are the two things. And then what I will going to do again, I will now going to induce this line and this line here. Okay, now I will going to write the dimensions here. Now, as you can see from this blue line, if you see clearly what do we mean by blue line, this blue line is actually representing the radius of this bigger ring. So it will going to be r. Okay, and what does this orange line representing? This orange line is also representing the radius. So it will also going to be r. And what does this brown line is representing? The brown line is representing the radius of this sphere into which at its maximum point of interface, this ring is being attached to. So this brown ring will going to have the length of r divided by 2. So from here, what we can find the angle. Okay, we can find the angle, the theta and the theta angle here. Now, this part is done. Okay, so now what I will going to do here. Now I need to support some calculations in order for this question to get completed. All right. So let us suppose now it has been given to us that the linear charge density corresponding to this ring was something like lambda. Okay, so the total charge is at surface of ring. What it will going to be? It will going to be 2 pi r lambda. Simple, as simple as fuck. Now what I will going to do? Now this 2 pi r lambda is being distributed uniformly. Okay, this needs to be taken into consideration. This has been distributed uniformly over the whole length, but we are only interested to find the amount of charges which are there in this region, in the 2 theta angle within 2 pi angle. So the total amount of inside charges, or QIN, in the sphere is like 2 theta divided by 2 pi of 2 pi r lambda. Okay, so canceling this 2 and 2, canceling this pi here, and going into the solution, the Qn will simply going to be 2 r lambda theta. And as per Gauss law, as we all know what Gauss law is actually, but if someone don't know, I will really tell him that Gauss law states that the line integral of the variable or non-uniform electric flux with respect to the area vector is equal to the total amount of charge inside the enclosure divided by epsilon naught. And I'm basically taking this calculations inside a vacuum. So I'm going to take epsilon naught only because here relative permittivity is 1. So it will going to be like 2r lambda theta divided by epsilon naught. This is the value of electric flux. Now electric flux is being denoted by something called phi E. Okay. Now proceeding ahead, the value of phi E at theta in the maximum state is like calculatable about 2r lambda theta by epsilon naught. 2r lambda theta by epsilon naught. Now we just need to calculate the value of theta. Then we are done. Now for that, we just need to go above to our original diagram, as we can see, and we need to have some erasers here because the things are taking up like messy. Messy means disorder, not that football player. Okay. So now what I will going to do is I will basically going to draw this whole thing as you can see here. Here, it is just like we are having a triangle. This is having length r, angle theta, and this length was r by 2, which is the radius of the sphere. So from here, by the application of cosine formula, I can simply calculate the value theta. Okay. So moving ahead here, by applying cos theta, it will going to be like 2r square minus r square by 4 divided by 2 times of r square. It will going to be like cos theta will be like 7r square by 8r square, r square will going to cancel each other out. And hence the value of theta that we have gotten here is like cos inverse of 7 divided by 8. Okay. So hence the value that we are required is 2r lambda divided by epsilon naught. Cos inverse of 7 by 8 is the maximum flux, which is our answer for this question. It was a very nice physics problem involving electricity concepts and trigonometry concepts, and various logical visualization is also being conducted to solve this question in a proper manner. So thank you very much if you have stayed with me until the last of this video. And I do like to say that even if I got negative 9 crore 9,099 social credits from Xi Jinping and John China will offer me an ice cream at the time of my execution, I will going to say Taiwan is a country. Bye.